Welcome to another episode on my Raspberry Pi 1 running Raspbian Linux using Tiger VNC to watch anything on my laptop, via my laptop. Electronics, including the fischertechnik, LDR, light dependent resistor, photoresistor, an ordinary LDR, ADC, analog digital converter, probes to the oscilloscope, and some software that is supposed to read in data from the sensors. Not to mention ADC thermistor and another resistor, everything connected to the ADC. Last time I received a replacement ADC because the other one, the original one, stopped working. And to my surprise, the new ADC didn't do anything either, which is theoretically possible, but in practice hardly. So what I want to do right now is to make, before I press enter on the program command, to make a measurement of voltage, because if the voltage is incorrect, it simply won't work. So what do? First of all, I will measure using the correct probe, of course. This is mass, and this is power. How much is on the power probe? 3.3 volts, which is exactly right. So since that is actually the position, and let me measure this one as well, it's 3.3 volts. Yes, that means that everything is correct on that matter. So the ADC gets its power. Now, what is on this side of the 10 kilo ohms resistor? 3.3. What is on this side? Decimal 08. Is that correct? I don't think so. I think so. So measuring here what is on this side of, and now I'm completely blocking the view, on this side what is the voltage right here on this large potentiometer? It is 3.3 volts. Is that normal? I don't think it is good to have the 3.3 volts. I don't think that is good. The full amount. Is it possible to have ruined it? It is. Not likely, but it is. Anyway, let me see how this works, if anything. And once again, it gives full 0. Now you can easily see that this LED is blinking, this LED is blinking. So the wiring PI pulse modulation is working. However, this is not, and if I put my finger on it, it doesn't work. And I know this one works because I'm using it with another project as well, and there it works flawlessly. So what to do? To be honest, don't know yet. And this has no sense. Next step is to check if the GPIO is actually correct. So I have removed on the other side of the cable from the GPIO, which you can see here as well. Now this is 0 instead of 1. Now that is something peculiar, because if this is 1, that means that the output does work. Let me check on that once again. So I reconnect the the cable to the GPIO, and you instantly see that this signal becomes 1. And if you look here, is that a good measurement? Well, CS is inverted. So 0 becomes 1, 1 becomes 0. So if this indeed is now, where are you? Right here. So if this pin, which is which is indeed 3, is inverted, it means that at least that part of the output is indeed correct, which is confusing. So taking the cable off again. Alright, and now without the cable attached I can do a pin test. And now I say, alright, do it. Pin 16 I know. But pin 16 is not being used in this experiment. But if I look at the other ones, yeah, I should actually give the pin numbers of the GPIO here, much easier to do. But in general, when I count them, and that is yeah, right here in front of my eyes, this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 23, 24, 25. And when I look at them, those are alright. So in that perspective there's no error. And here you can see that they indeed are correct. And that excludes the GPIO as an error. Simply an exclusion. So I have to look somewhere else on the board again. And and once again that doesn't make this any easier, none at all. So CE0 I should say, CE0 works because that is inverted, and these are also alright. So what to do about that? Very good question. So with this result, I've added now the pin numbers to the schematics. Easier to read, easier to do. Time to reconnect the band cable with the GPIO and then see if this is alright again. And it's not. Why is this not alright? Is the band cable alright? Let me take it off. And carefully put it on again. And it doesn't do anything. It doesn't do a thing. So where it was 1, I don't measure anything now. So not quite sure what the reason is. I have to check on this wire. And then make sure it is connected nicely. And it is all 0. And that is suspicious. So I am now going to reconnect, to disconnect the power. And the probes here are not as nice as could be. So disconnect power and reconnect power. And right now it is really off. So what is the reason for this? Do I have to reboot anything or everything? This makes no use, of course. Everything is still 0. But what I can do is using multimeter once again and measure on that one port. So 1 to the mass and 1 to, which is this one, and that is right on. This is IC, which is 0 indeed. It is 0. And this is 0.4, 0.04, this is 0.01. So the output is indeed 0 now. That's not good. So chip select C0 device 0 is now to 1. So why is it? I think I better reboot the whole thing and see whatever that brings. This is curious, very curious. Yes, time for a reboot. After a reboot, what has changed? Well, I don't know yet. First thing, this hasn't changed yet. After the initial change, what did change? Directly after the reboot, CE0 becomes 1 again. So if this works, why don't the others? And let me see for certainty. Is this E0? It is on, let me measure, let me check. It is this probe, which is attached to this wire, which is attached to the only wire on the even side. The only wire on the even side is CE0. So then attached are 23, 21. No, there are only let's see which one is this one. That one is 19. 19 is not attached. 19 is master output slave input. What difference does that make? I am not quite sure actually, but I might connect that one as well. So let me find a little wire and attach a probe. Good idea. And probe number 4 attached, which gives totally 0. Now all these signals are probed, but the only thing that actually shows something right now is this one, which also is caused, of course, by not running the program, but I don't think that doesn't matter, doesn't mean much. So let me first run my own program, and gives absolutely 0. Not quite surprising considering the previous results, but then again, nah, it should have worked immediately. Alright, then ADC test. All 0. Alright, let me do something else. With my own program. It is set now to milliseconds. So if I shorten that time base, to half a millisecond, do I see something? I do see something now, but is it what I expect? Let me change the time base again. I see spikes. It is 0, all 0, but oscilloscope shows something different now. Now it is 100 microseconds, 1/10 of a millisecond. Let's see carefully what happens. Do I see something here? I see nothing now. I remove my finger. Do I see the spikes again? A little patience. Or a lot of patience maybe. But what do we see on the oscilloscope? Spikes. And the remarkable thing is, on my other project with the Arduino Mega 2560 and Arduino Uno, it spikes only as well since recently. So how come? So this means that the SPI will be working. Otherwise I wouldn't see spikes either. So what is the conclusion about for this? Apart from, of course, being all these output screen output values being 0, which I don't like at all. But this would mean that the SPI does work for some reason. It does work somehow. And I don't get it. How, what, when, etc. Another thing I can test, of course, is not just this one, but the ADC test. And not that there are will be different outcomes, but I can at least look here. Will there be anything different at all? Let me decrease the time base once again. 50 microseconds. This is odd. Why don't I see spikes now? This is strange. Spikes. I do now see the spikes. So let's quit this one again, go in the other one. This is using SPI as well. It is specifically for the MCP3008. Why do I not see spikes? Another thing I can't explain. Nope, no spikes. Back to my own program. Spikes. Yeah, alright. It does use the SPI SPI-Def, I know. And then I'm talking about this. It uses exactly the same. So why do I see the spikes here? That proves that the SPI does work. But then why do I get no values read in? Very peculiar. Very strange. Anyway, lots to think about. I have, by the way, contacted the supplier again, and I haven't got them yet because they were as surprised as me to hear that the ADC visibly, at least, doesn't work, and it is a brand new one. Technically it can, of course, a defect on arrival. On the other hand, it is so very unlikely that it happens. Anyway, if you like this video, please subscribe to my channel if you haven't done so yet. Give it thumbs up. You can also follow me on Twitter, retweet and like. You can follow me on Instagram and like. If you you can leave comments if you want. Some people actually do. Thank you for those comments. And please donate to keep videos coming to you. Very much appreciated. More information on my website about donation and how to donate, and this is going to be continued, obviously. So for now, thank you and bye bye.